So, I'm not sure, maybe Thursday, Friday. So, we'll just see. I don't know. I don't know that we'll get to it by the end, but we'll see.
You're putting us through the
Okay.
ringer. 3 tests in 3 weeks.
So, we're fixing to start on chapter 2. We're gonna cover 2.1 and 2.2, and then we're gonna have a test. The most difficult skill, hey, the most difficult skill is going to be, what you learned today, okay? But everything that we do today, you should have learned in Algebra 2.
Is it your birthday?
What? Okay, yes it is. Alright, but they don't call it that. Alright, so here we go. 2.1 is on quadratics. You'll have a test on 2.1 and 2.2. I won't quite get finished with 2.1 today, but I will come close. So I will do this for you, okay? So last time I waited until the day before the test and gave you the review. So I'm going to give it to you 2 days before the test because I felt like maybe some of y'all, I don't know, probably had something better to do. But anyway, still, so you might have been pushed if you had like practice or something like that. But most of those kids got it done. But some of the other kids found something better to do, and they didn't do my worksheet. Hurt my feelings, but whatever. All right. So this is on quadratics. Tell me what makes a quadratic.
Squared.
Okay, so it has to have an x squared in it. You with me? What's that look like when you graph it?
Parabola.
Okay, so the parent function is this. Do you agree?
Yes.
Vertex at 0, 0. What is this line called that runs down through the vertex?
Axis of symmetry.
Very good. So this is my axis of symmetry. Does symmetry have 2 M's? Me neither. Oh well. I can't even spell it now, so I'm just gonna abbreviate it. So this is my axis of symmetry. It is, I could fold it on the axis of symmetry and one side of the parabola would land on the other side of the parabola. Okay? So, guys, listen to me. Everything that we're going to do today is an Algebra 2 skill. Okay? Could I toughen it up and make it a little more difficult? Yep, I could put some nasty numbers in there, things like that. But, other than that, this is pretty much a review. So, let's do example 1. Example 1, they want me to describe how each graph is related to y equals x squared, which is called your what? Parent function, okay? So, basically, they want to know transformations, people. That's all they really want to know, okay? That's how you describe how it's related to it. So here's my first one. F of x is equal to 1/3 x squared, okay? 1/3 x squared. So you can see that the only thing I've changed is I put a coefficient of 1/3 on my x squared, my quadratic term. Tell me what that does.
Compression.
What kind of compression?
Vertical.
Vertical, very good. In order for it to be horizontal,
Bigger than 1.
now it would need to be in parentheses. You would need parentheses around this, and then it would be squared, okay? And it would actually be a horizontal stretch. Y'all, if you stretch something horizontally, isn't that kind of the same thing as a vertical compression? Do you see what I'm saying? All right, but vertically it does, horizontally it does the opposite of what you think. So this is a vertical compression of what? 1/3, okay? So if I wanted to graph this guy, then my vertex is still at 0, 0. All right? For my next 2 points, could I go up 1 and to the right 3 and the left 3?
If you want to.
Yeah. Wait, open it and vacuum it too.
I said, for my next 2 points, y'all, it's a parabola, he opens
Yeah,
up.
yeah.
Okay, for my next 2 points, could I go up 1 and to the right 3 and the left 3?
No,
Why?
because you can only go up your slope once.
You can only go out
Out.
1,
Once.
okay? You can only go out 1 unit, y'all. You cannot go up 1 and over 3. So how would I have to do that 1/3 to get those next 2 points?
Go up a third and over one.
Yes, go up a third and go over 1, and then to the left 1. And there is my parabola.
Wait, go up a third?
Uh-huh. You have to treat this number like it's not a fraction, yeah. Like you have to treat it it has to be something over 1. So I'm gonna go up that much, and then you can only use that when it's a curve. You can't use it like a slope, all right? You can't go up 1 and over 3. You can only go out 1 unit on either side, okay? So I was just seeing if y'all remembered that, because we had talked about that earlier this year. All right, so here's the next one. G of x is equal to 2x to the second. All right, anybody want to tell me?
Vertical stretch.
Of 2. You have to tell me what it is, okay? A vertical stretch of 2. Okay, very good. Amen.
So it's a compression if it's less than 1, it's a stretch if it's more than 1?
Yes, if it's between, and we say it's between 0 and 1, because you're really kind of taking the sign off of it. The sign tells you if it opens up or down, okay? So just look at the number, the absolute value of A is what you're looking at. But yes, if it's greater than 1, and we're gonna talk about that in a second, but yeah, I'm just seeing what you know. So everybody okay with this one? So his vertex is at 0, 0. So this time, can I go up 2 and over 1?
Yes.
Yes, you can, because you're only going over 1, all right? But that's the rule. In order to use this number, you can only go right or left 1 unit, all right? So here's what he looks like. And you can tell he's narrower, this one's wider. All right, everybody okay? Here's my next one. H of x is equal to negative x squared plus 1. When you tell the transformations, I want you to tell them in the proper order.
I don't know how to do that. I forgot like completely.
It makes your parabola open down.
That's exactly right. So if there's a negative on the y, like this is, that has to be the very first thing you address. You don't want to say that it moved right, and then it moved up, and then say, now you have to reflect it over the x-axis, because that's going to change everything, okay? So the first thing you're going to address is if it's reflected over the x-axis, which means there's a negative on the y. So this right here, you're going to reflect over the x-axis. And remember this, if the negative is on the y, now look, let's address this one more time. How do I know this negative is on the y when he's sitting in front of the x? Yeah, he's not in parentheses. If he were on the x, this is what he would have to look like. That's on the x, okay? So, this is on the y. If he's on, whatever he's on, he reflects it over the other guy's axis, okay? So, here he is, he reflects over the x-axis. That just means he opens down, people. That's just a fancy way of saying that, okay? What else?
Up 1.
Up 1. Okay, so this is what he's gonna look like. I'm gonna try to stop saying okay 900 times, my husband got on to me. Sorry. It's gonna be very hard because I say it
That's
a
okay.
jillion times.
That's okay. That's
Alright. I'll find another word and put in there. Okay. Sorry. Oh, this might not be the class to do this thing. So, this negative, he reflects him over the x-axis, so now my parabola is opening down. This is a y. He's not with an X, so he doesn't move it left or right, Y's move up or down, just like you think. So now my vertex is up here, and he looks like this. Everybody got it? D. I didn't say it. K of X.
Wait, what goes in front of K?
D.
Okay.
I knew you were thinking that. Alright, so
No, bro, okay.
open up the parentheses, negative X plus 2, quantity squared minus 3. This is one of the most difficult ones. When you put that negative on that X, that makes it more difficult. And when do you do that? When do you do that? Yeah, this is the last thing. If it's on the Y, it's the first thing. If it's on the X, he's just the opposite. It's the last thing. Okay?
Why is
Or,
that?
sorry, I'm never gonna do that, so whatever. I quit. Alright, so what's the?
Quit what?
Okay.
Oh.
So, tell me what you're gonna do first. What's your first transformation?
Down 3.
Left.
Yeah, left
Left
2 and
two.
down 3, and those, the order doesn't matter. It doesn't make any difference, okay? I just read across, so I would say left 2 first, but that order does not affect anything. And down 3. So you could switch those around and you would be okay. So, you would be fine. Left 2 and down 3. So really what's happening is you got a parabola whose vertex is right here, and he looks similar to this. Are you with me? But, what? Over the,
Y.
very good. So this negative on this X reflects over, and he always does the opposite axis. So if it's on the X, it's over the Y axis. Okay? And these are the more difficult ones. So now he was left and down 3. When he reflects over here, he will be right 2 and down 3. He just has that 1, so I could do that for my other 2 points. Just go up 1 and to the right 1 and to the left 1, and my parabola actually looks like this. Whoa. Alright, anybody got a question?
Why does it not look like? Oh wait, never mind. I'm kidding.
Like he looks perfect, what's the matter with him? Alright, so, let's move on to the next. Now this was good, right? Everybody okay with this? This is not bad. Everybody should know how to do this. We've talked about this not just this year, but you learned it last year, and then we've talked about it this whole entire year. All these things that we talked about, they dealt with the sine curve and cosine curve too, alright? So even last semester, we, spoke about them. Alright, so now let's talk about standard form. Now here's where a little bit of confusion comes in, okay? Standard form. So last year, the books that we used in Algebra 2 referred to standard form as ax squared plus bx plus c. Y'all remember that? Okay. This book, our pre-cal book, refers to standard form as what we know as vertex form. So I'm gonna try and say it both ways, all right? But I have to use this standard form because my test generator is taken from this book. He's generating my test from the book, and so he's going to use that vocabulary. And if you don't know that that's really talking about vertex form, then you'll get messed up, all right? So, does anybody remember what the vertex form of a parabola is?
AX plus BY
Wow.
equals.
Stop that. A, yes, Sean, A times x minus h, quantity squared, plus k. Why do we call it vertex form? People, you can look at it and scream out the vertex, okay? So what is his vertex? Yeah. H, K. I don't have to find it or anything. It's standing there looking at me. What did you do to this guy right here?
Multiplied on by.
Yeah.
Is it,
Yeah, he's to change the sign, all right? change the sign. Sometimes you can think about it like he's an X. What do? They do the opposite of what you think, okay? So you're gonna change his sign. What about this guy? Keep his sign.
If it's like x minus 3, like.
Then it would be 3.
Okay.
Mm-hmm. So whatever is in here, when you pull it out and tell me it's vertex, you're going to change the sign, all right? What about my axis of symmetry? Because I'm going to ask you about that. We talked about it right here, how it goes. We draw it with a dotted line, okay? And because it's not really part of our graph, it could help you graph, but it's not part of our graph. So what kind of line is this?
Vertical.
A vertical line. How do you define a vertical line? How do you write the equation for it? X equals. And if it has to go through the vertex, what does X have to equal?
H.
H. See? Right there. All right? It must be written X is equal to. If you just write the number down, I'll mark it wrong. I won't give you any credit for it. Okay? It is not a number. It is a line. Okay? So let's talk about A, and this is what y'all were speaking about earlier. So if A is negative, what does that tell you about my parabola?
Down.
Yeah, he opens down. Right? If A is positive,
Up.
yeah, he opens up. And then this is what Aiden was asking about. I'm gonna talk about just the number. I'm not gonna talk about his sign. So I'm gonna put an absolute value sign around A, okay? I wanna disregard his sign, because when I say he's less than 1, I'm not talking about negative numbers, okay? So I'm gonna say, if the absolute value of A is greater than 1, that will be a vertical stretch. It will make my parabola narrower. Okay? If the absolute value of A is less than 1, but greater than 0, okay? He's in between 0 and 1, then that's gonna be a vertical compression, which you could also call, we used to call them shrinks all the time. But then they started using the word compression. Now I've seen them go back and kind of start using the word shrink again. So just, they both mean the same thing. And that's gonna make my parabola what? Very good. Anybody got a question? All right, so let's do example 2. Example 2. Put the quadratic in standard form. Now, what is standard? I mean, what is standard form? Sometimes in our brain. Yeah, it's vertex form, guys. Okay. Last year we called it vertex form. That's what our book called it. Okay. And so you need to make sure that you understand when they say standard form, they are not talking about what you called standard form. I mean, we say standard form for a polynomial is to start at the highest exponent and go down. But your book is not calling it that. It's calling vertex form standard form. This right here will be the first page on the test. First page on the test. It's going to be 3 problems. No calculator. All right? No calculator. You're going to have to know how to complete the square, because that's what this is. It's an Algebra 2 skill, so you should be okay with it, all right? But you will not have a calculator. Why? Because you could just put it in your calculator and go second and calculate the minimum or maximum. You could find the vertex, and then you could just pop it in there. Okay, we're not doing it that way, people. We're doing it algebraically, so you're not allowed to use the calculator. It'll be a pink piece of paper. When you get finished with that piece of paper, you can turn it in to me, and then, I'll give you the white sheet of paper, and you can finish the rest of the test on that day with a calculator.
Did we do that exact thing last year? Like a
Yes.
whole page and a white page?
Yes. Trying to train you for this year, okay? So, here we go. I'm gonna do one, and then I'm gonna let you do one over here. So, here's the one I'm gonna work. F of x is equal to x squared plus 6x minus 12. Alright, so the first thing I'm gonna do is I'm gonna go up here and I'm gonna show you what we're trying to accomplish, okay? We're trying to accomplish a number out front. This number will be whatever is in front of the x squared. Obviously here it's a 1, so it's not gonna be a big deal. Then I'm trying to create a binomial square. And then you'll have some numbers out here. So the first thing I'm gonna do is I'm gonna create a perfect square trinomial so I can write it as a binomial square. So here's the way you do it. You always take the x's and you kind of separate them off and put this little plain number, this constant, out here by himself. Push the x's together, leave a space, okay, because we're gonna make a perfect square trinomial so that you can write it as a binomial square, okay? So, anybody remember how you complete the square?
Not
Is
it.
it something with like a rainbow?
Divide.
We do, parts of it we use a rainbow, we're not yet.
Divide B by 2.
Yeah, you take this 6 and you take half of him. That's my b, ax squared plus bx plus c. You take half of b. What's half of 6?
3.
And then you square it. What's 3 squared?
9.
And then you add it right here. Always add, because no matter what sign is right here, when you square it, what will it always be? Positive. Okay? Now, did I just change the problem? Yeah, people, we just changed the problem. We just said plus 9. Okay, so what do I need to do out here to undo that?
Subtract 9.
Yeah. Notice how everything, when it's in standard form, stays on one side. You don't have anything over here, okay? So, now we're gonna write it. Here's the binomial square. It's gonna be the square root of the first. Keep this first sign. Y'all, the last sign will always be a plus. Whatever the first sign is, that's the sign you keep. So this one's a plus. What's the square root of 9? What's half of 6? Do you see what I'm saying? They should be the same number. If they're not, you messed up somewhere. What's negative 12 and negative 9?
Negative 21.
That's it. What's my vertex?
Negative 3.
Negative 3, negative 21. Are you with me? What's my axis of symmetry? X is equal to negative 3. Does he open up or down? Is he wider, narrower, or the same as the parent function?
Same.
Very good. You with me? Bringing back some good old memories, people. All right? You ready to try one for you?
Sure.
You try this one.
Don't make it too long.
Okay, I'll save that one for next.
Oh,
X squared minus 4x plus 7. Mhm. that what y'all got? Does anybody have a question? Be sure, y'all, this sign is very important. You have to take that first sign. What's my vertex?
What did you take half of it? I still somehow got the right answer. but-
What's half of 4?
2.
What's 2
Oh,
squared?
8 squared. 2 squared.
It's 4, but then how did you get to x minus 2 squared plus 3?
Square root of the first, keep the sign, square root of the last.
Oh, okay.
What quantity squared gives me this? Remember, when you
Yeah.
square a quantity, what do? Square the first, keep the sign, twice the product, plus square the last. What's my vertex?
2, 3.
What's my axis of symmetry?
X equals 2.
Is it open up or down? Wider, narrower, or the same?
How are you doing that part?
It's A, whatever A is out here. It's a 1, so he's the same as the parent function.
And it's positive, so.
And he's, yes, so he's positive, so he opens up. It's talking these things right here.
Yeah.
Okay? All right, so let's make it a little bit more difficult. This is B. We're gonna follow the same outline, people. I'm gonna work one, and I'm gonna give you one to work. So f of x is equal to 2x squared plus 8x plus 7. All right? 2x squared plus 8x plus 7. All right, so here's a rule. You need to know this rule. You cannot complete the square unless the coefficient of the quadratic term is 1. Y'all, that means that the coefficient of x squared has to be 1. And if it's not, then you have to make it 1. Okay? So, whatever is out here in front of the x squared, if it's not a 1, you have to factor it out. And you only factor it out of the x's. Okay? You only factor it out of the x's. So you pull a 2 out. What do you multiply 2 by to get 2x squared?
X squared.
Okay? What do you multiply 2 by to get 8x?
4x.
And then you don't do the 7.
Leave a little space, and then you put your little 7 out here. Okay? Anytime I factor something out, I draw the rainbow in a different color so it stands out for me, because that is where the most careless mistake is going to be made. Okay? That's where kids make more mistakes than any other time. And you're going to see in a minute. Now let me ask you this question because of what's going to happen. Let's say you're going to factor something out. Let's say that this was a 9 right here. 2 doesn't go into 9. Factoring out is the same as what? Dividing. So 2 divided by 2 is 1. Guess what 9 divided by 2 is? 9 over 2. 9 halves. Okay? So just remember that. All right, so let's go on about our business. We got us a 1x squared right here, so we're good to go. What is half of 4?
2
2 squared is?
plus 4.
So I add 4 here. But did you really add 4? Yeah, the distributive property says you got to multiply that by a 2, and you really added 8, so what do you have to do out here? Very good. So don't drop your 2, okay, because he's affecting the shape of your parabola. And then you get square root of the first, keep the sign, square root of the last, quantity squared. What is 7 minus 8? What's my vertex?
-2, -1.
Very good. What's my axis of symmetry? X equals -2. Does he open up or down? Is he wider, narrower, or the same? Narrower. That's a vertical stretch, okay? So a vertical stretch of 2, that's going to make it narrower, skinnier. All right, are you ready? Here's yours. Oh, sorry. Stop. Don't pay attention.
Yeah, don't put a fraction.
Now pay attention.
Would you rather fractions? Do you want fractions?
Yes, I don't want decimals. No decimals and no mixed numbers. All right, are you ready? Okay, so I have to factor the 2 out. Y'all, you cannot complete the square until you get that coefficient to be a 1. Who do I take the 2 out of? Just the x's. Anything that has an x, you have to pull it out. Other than that, the little constants of the plane numbers will be out here. So what do you multiply 2 by to get a 2x squared? X squared. What do you multiply 2 by to get a negative 5x?
2.5x.
No
Oh,
decimal.
2 over 5 over 2.
Yeah, all you do is take this guy and you divide him by whatever you're trying to take out, okay? If it reduced, I would reduce it, but 5/2 doesn't reduce. So he becomes 5/2 x. Now look, guys, you can check this. What is 2 times x squared? 2x squared. When you multiply this by 2, what happens to those 2's? It cancels out and you're just left with minus 5x. Okay, I am going to draw that rainbow, all right? I'm going to take half of this. Am I going to divide it by 2? No, I'm going to multiply it by what? A half. So I'm going to go over here and I'm going to write this down, okay? I'm going to say, what is 5/2 times 1/2? What is it? 5/4. And then what do I do with 5/4?
Square it.
You square it. You know how you square a fraction? You square the top, you square the bottom. What's 5 squared?
45.
And 4 squared. Okay? So it looks like I added 25/16, but I gotta multiply it by 2. If you don't know what that is, go over here and do a little chicken scratch. 25/16 times 2/1. Always cross cancel, guys. So 25/8. You with me? So what do I want to do out here? Subtract 25/8. Okay, you with me? So now I have 2, square root of the first, keep the sign, square root of the last. Y'all, there it is, right there. Okay, that's why I like to write it down. I don't even have to think. 5/4, quantity squared. Over here, what do I need? Between 1 and 8, what is it?
8.
So this guy, you multiply by 8, so you multiply the top by 8, and you get a positive 24. This guy's already over an 8, so minus 25 over 8. What's 24 minus 25? So what's my vertex?
5/4 negative 1/8.
Perfect. What's my axis of symmetry? Is he open up or down? Is he wider, narrower, or the same? Very good. Anybody got a question? Okay, so now I'm gonna add something to it, all right? So all I've done is add, just keep adding a few things. So this is example 3. Now, I'm gonna tell you this. On my paper, on my notebook paper, this took up a half of a page, okay? I think it would be better if you kept all of these things together. So So if you have less than a half a page, you might wanna go to the next page. On this paper, I'm gonna write a little bit bigger, so it'll probably take up a little more. So, example 3, describe the graph and tell the x-intercepts. Okay? Describe the graph and tell the x-intercepts. Now, when I say the word describe, this is what I'm looking for. Okay? I'm looking for the vertex. I'm looking for the axis of symmetry. And I'm looking for any transformations. Okay? I want the vertex, the axis of symmetry, and any transformations. So, here is my problem. F of x is equal to negative x squared plus 6x minus 8. So the very first thing we're gonna do is we're going to complete the square. Do you want, let's do it together so we have enough time, okay? So what do I have to do? Yeah, y'all look, this is not a 1, it's a negative 1. You cannot complete the square unless the coefficient is a 1, positive 1. So you have to take the negative out. If you want to write a 1 there, you can, but you don't have to. Who does the negative come out of?
Everybody.
No,
X's.
only the x's, okay? So I'll get a positive x squared, and what will this become? Negative 6x. He's just gonna change everybody's sign. Leave me some space to complete the square, and then my minus 8 goes out here. I do draw this because I know that's probably one of the most common things I do wrong. All right, is everybody okay so far? Yes? All right, so it's half of 6, 3 squared. So I added 9. But did you really add 9?
Minus 1.
Yeah, you really subtracted 9 because negative 1 times 9 is negative 9. So what do I have to do out here to undo that negative 9? Add 9. So now he looks like this, negative, and you can have the 1 if you want to, you don't have to if you don't want to. Square root of the first, keep the sign, square root of the last.
Why did this take your whole page?
Quantity squared, because of what we're fixing to do when we find the x-intercepts. Okay? And then plus 1. Are you with me?
Yeah.
All right, so what's my vertex?
3, 1,
3, 1. What's my axis of symmetry?
3.
Don't say 3, it's wrong. X equals 3, very good. Tell me what my transformations are. What's the first one?
Reflect.
Yeah, you have to do this guy first, guys. If you got a negative on the y, which is that little a out there, okay, then that's gonna be the first thing you wanna do is turn that thing upside down. So he reflects over the x-axis. All right, and then what transformations?
Right there.
Right 3 and
Up.
up 1. And those could be flipped. If you do them the other way first, it's fine, it doesn't matter. Okay, the negatives are really the only thing that matter. If it's on the y, it goes first. If it's on the x, it goes last. Okay, so there are 3 ways to find the x-intercepts. Okay, so here's the first way. Factor. All right, so I'm going to look at this original equation right here. I'm going to set it equal to 0, okay? Because I'm trying to find his x-intercepts, and that will be where y is equal to 0. All right, so he'll look like this. 0 is equal to negative x squared plus 6x minus 8. Guys, listen to me. I am not going to factor with a negative on my quadratic term. He makes all the rules that you learned about factoring not apply. Okay, so it makes it very difficult. So I'm just going to get rid of that negative. I'm going to divide everybody, both sides, by negative 1. What is 0 over negative 1? 0. And all he does to this guy is do what? Change all his signs. So he becomes a positive x squared, a negative 6x, and a positive 8. So now I will factor him. Are you with me? What does x squared factor into?
X minus two.
X and x. What's a plus sign at the end mean?
They're both same sign.
Yeah, same signs. They're gonna be the same as this guy right here, okay? So both are gonna be negatives. The factors of 8 are 1 and 8, 2 and 4, 3 and nothing, 4 and 2. Who adds to be 6? Okay, so let's see who remembers. X minus 2 is my factor. What's my root? What's my x-intercept? What's my answer? What's my solution?
Positive two.
Yes, positive 2. If you don't know where that comes from, all you do is set this factor equal to 0 and you solve for x. You add 2 to both sides. Okay? Remember this. If there is a number in front of x, what do you have to do with that number? Divide by it. Okay? So over here, if x minus 4 is my factor, what's my root? 4. So these are my x-intercepts. 2 and 4. Okay? Now, what if it didn't factor? How would I solve it? Oh, okay. So if this thing doesn't factor, then I can go over here and I can do the second way, which is the quadratic formula. Alright? So let's see who remembers that. X is equal to. There was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. Okay? So, this is my equation, guys. My equation is this guy up here, negative x squared plus 6x minus 8. So tell me what A is.
Negative one.
Tell me what B is.
6.
Tell me what C is.
Negative 8.
Very good. So, what's the opposite of B? Negative 6. Plus or minus the square root. Remember, will you have a calculator? No, you will not have a calculator. Okay? What is 6 squared? 36. Minus 4 times what's A? What's B? No, C, pardon me. Negative 8. All over 2 times negative 1. Alright, so look right here. So I'm going to go out to the side and do this guy. 36. 3 negatives make a what? Negative. What's 4 times 8? What is 36 minus 32? 4. So I have negative 6 plus or minus the square root of 4 over negative 2. Are you with me?
Yes.
Everybody okay so far? So what is, that's negative 6 plus or minus, what is the square root of 4? 2 over negative 2. So I'm going to separate it, guys. This is just 2 problems. I got negative 6 plus 2 over negative 2. What's negative 6 plus 2?
Negative 4.
So negative 4 over negative 2. And the other one is negative 6 minus 2 over negative 2. What's negative 6 minus 2? Over negative 2?
4.
Here's my 2 and my 4. Just like I got it there. Okay? Now, are you ready for this?
I have no room.
Or,
Guessing.
this is the easiest way. This is my favorite way. This is the way I would do it. Okay? This is the way I would do it. I would, huh?
I think you just graph it.
Because you won't have a calculator.
But like, you can just graph it.
Stop. Like in your brain?
Yeah, right? You just do the transitions, right? 3 up 1, and you just graph it. There's no.
Well, if you graphed it, it would take you a lot longer to do this.
You can graph it, Brandon, if you want.
Okay?
Do it right now.
Does it have a lot of?
Now, I'm gonna say this, okay? Brandon, look, because this is what's happening.
minus 3
Brandon,
squared plus
this thing only
506.
goes up one time.
Or the X-Intercepts.
So he used that negative one and he found those, all right? So, now, they're not all gonna be like that, all right? I would venture to say none of them are, all right? And I wouldn't do that.
How much room does this
So
take?
here we go. We gotta hurry up because I only got 5 minutes. Here's the way I would do it. I would take what you put in vertex form and I would set it equal to 0. Okay? I'm trying to solve for x. So the object of this game is to get whatever's squared all by itself. And then I'll take the square root of both sides. So tell me what to get rid of first.
The negative one.
No. This positive one.
That's what I meant to say,
Yeah, so
sorry.
you're gonna minus 1 from both sides. So this goes away. 0 minus 1 is negative 1.
Yeah, okay, yeah.
Now what am I gonna do? Yeah, now I'm gonna divide by this, y'all. You can't, that's not by itself, okay? So divide by negative 1. What's negative 1 over negative 1? Now what do I do? Square root that guy. Okay, over here they cancel out and x minus 3. Over here, what's the square root of 1?
1.
Yeah, plus or minus 1.
Oh.
And then I'm gonna take this little negative 3 and I'm gonna push him over here and change his sign. And it's gonna be x is equal to, I'm really adding it to both sides, guys, but it looks better and it makes you do it better if you put it on the front. 3 plus or minus 1. People, what's 3 plus 1?
4.
What's 3 minus 1?
2. What's the name of it?
Wow.
What's the name of what? It doesn't really have a name. It's just using your vertex form. Wait. Write that down, that's your homework. I'm okay with that. I'm just, that's, more kids make more mistakes when they do it that way than they do it the other way. So that's all.
What is this new?
Bailey, I took a
Travis?
Travis, don't be a nuisance.
Stop it. No.
Don't be a
What is this?
A nuisance.
We're gonna look at them tomorrow. Do them tonight,
neither.
guys. Or do them at school in somebody else's class. No, I didn't say that, sorry.
Is it a grade?
I don't know. I know.
No, I'm saying
Probably Brandon, sorry. Wait, what did she say? I did say Brandon one time.
Out of like 10.
No, 2 times.